Welcome to my channel, STEM Cafe. Here I make everything science, technology, engineering, and mathematics. Easy to compare, assimilate, fun, and entertaining. Today, I would like us to treat decimal numbers. This is an aspect that is, it covers every aspect of mathematics. And it's good we treat it. Anyway, for those who are still, coming up, and to be able to simplify the handling of decimal numbers. When you look at the numbers we use, it is the number base of 10. How do I mean? If you look at it, we'll do something like this. This is from 0 to 9. The next one will be from 10 to 19. You can see, when it comes to the next stage, it continues like that. The next one will be 20 to 29, until we get to 90. And then, you can see, initially we have units. Later we have tens, double. And afterwards, we have 3 numbers. By the time we continue like that, we'll be having 4 numbers, 5 numbers, 6 numbers, etc. But that is why we have it as whole numbers. But sometimes we may not have whole numbers. A number can be divided by another number. And then we will have, a portion which is not whole. Let me give you examples. Look at this number. 17 divided by 4. Because 4 is not a factor of 17, we are going to have smaller numbers at the end of the day. Let's look at it like this. 4 in 17, we have 4. Remaining 1. 1 over 4. You see? But sometimes we might not want to express our numbers in this kind of fraction. We want to express it in another fraction, which is in tenths. And I have to express this one with decimal numbers. So it's going to be something like this. 4 points. Because it's not up to a whole number. So this one will make it to show that we have a smaller numbers in tenths. Now look at this. 4 in 1. Not going. That's why you put points. 4 in 10, 2. Again, 4 in 2. Because 2 is not as big as 4. So I have to write, to make the 2 there. Put another 0 behind the 2. 4 in 20 now, I have 5. For you to understand it easily, look at what I have here. This one. 4 here. So now, what do I have? I have 1 here. 4 in 1. It's not going. So I have 0 points. You can see. 4 in 10. I have 2. You can see. 4 times 2, 8. That is 2. 4 in 20 now, 5. 5 times 4, 20. So you can see, I have completed it. Or if you want to do it wholly like this, don't do it like this. 17, 4. 4 in 17, 4. 4 times 4, 16. 1. 4 in 1, it will go. So you put point here. 4 in 10, because it is in tens. We have to be, introducing 0 behind the number so that it will be increasing. But it's not that it is increasing in significance. It is increasing like the point here. The number is not really increasing. Now, let me put it like this. When I have put points now, it has shown me that it is not up to the whole number again. So I put 0 now, so that the number will be divisible. 4 in 10, now I have 2. 4 times 2, 8. You can see. 2 here, because that is 10 minus. So I have to introduce another 0 here, so that it makes sense. Now, you see what I mean. 4 in 20, 5. 4 times 5, 20. Now, you realize that as I was dividing, either here or there, I was introducing 0. Now, if I have this number now, I put 0. This number increases. Because it has become 10. If I had another 0, it has become 100. But if I have a number like this, if I put 0, this number value is not changing. If I put another 0, it is not changing. That's what I was trying to explain here. No matter how many times you are dividing, and you are subtracting, and you are adding 0, the initial value of the figure is not changing. The 0 is just coming there to make it possible for your operation to be carried out. If you put 10 zeros here, it doesn't change the value of this. That is what has happened here. So, when you are dividing a number with another number that is not its factor, you are going to have this. And we always have this kind of, we call it decimal numbers. These decimal numbers is a kind of fraction that is expressed as like dividing by 10. Like you are dividing the number by 10. You will see what I mean now. Now, when we are talking about numbers in mathematics, I try to tell you, if you start the number like from 0, you stop at 9. But most times, we start from 1, and then continue at 10, 11, 20. It's always good you look at it from this standpoint. But we are used to this. So either way, but mine is your comprehension. What I'm concerned about is your comprehension. So always look at it from this perspective. Now, if you look at this, let me say I have 1,230 and 34. You know what this number is? It means 4 times 1 plus 3 times 10 plus 2 times 100 plus 1 times 1,000. You understand? So I'm going to have 1,000 plus 200 plus 30 plus 4. That is why we are having the number, whole numbers. Whole number. When you break it down, this is what it will give you. Now, I want to tell you something. When you see something deci in mathematics, deci, it means that's, that number or that unit is already divided by 10. Look at this. When you say decimeter, it means 1 meter divided by 10. Decigram, it means 1 gram divided by 10. So what we are saying now is that this deci is numbers divided by into 10 units, divided in tens, in units of tens. That's what we mean by decimal numbers. So now I have told you about whole number. So which means that if it is in decimal numbers, it means it is being divided. It is being divided. Look at our real numbers now. 1,000, 100, tens, and units. You can see that now. Now look at this number. 1.234. I told you, when it was our normal number in tens, base of 10, it will be increasing and be multiplied by greater powers of 10. In this instance, this one is 1 plus 2 over 10 plus 3 over 10 over 100 plus 4 over 1,000. Can you see? 3, 4. You can see now. You can see. So, when we are talking about decimal numbers now, we want to express it in this manner. That we will know that the numbers, as they are getting further from the decimal points, their significance is reducing. Their significance is reducing. Look at this one now. The 2 before, immediately after the point, has greater significance than this one. This one has greater significance than this one. That is what we mean by decimal numbers. It is the division is continuously by 10 backwards. And we have already spoken about what generates decimal numbers. That is, when a number is divided by another number which is not its factor. Now, you can see 1 plus 2 over 10 plus 3 over 100 plus 4 over 1,000. Just have this in mind. Just have this in mind. It will always be like that. Look at another number like this. Let's say 3 over 5. 3 over 5. 5 in 3. Not up to 1. So I put 0. Points. I add 0 to this one. Just like this one now. I put 0 here. It will give me 6. You can see. It will give me 6. That is what it's equal to. I told you that once you add points now, any other 0 you add after it has no value. But for ease in handling the division, you can be adding zeros and continue the operation of division. I think with this, let's look at maybe another one. Let's look at something like 3 over 7. 7 in 3, not up to 1, because it's bigger than 3. I put 0 points. 7 in 30, that is 4. 4 times 7, 28. Because I have 30, I have 2 now. 7 in 20, I have 2. 7 times 2, 14. 14 from 20, 6. 7 in 60. I have to put 0 after that 6. 7 in 60. What is that one going to give me? It's going to give me 8. 7 times 8, 56. What do I have? 56 in 60, it will give me 4. Now I put another 0 behind that 4. I'm going to have 40. 7 in 40, I have 5. 5 times 7, 35. 35 from 40, I have 5. So 7 in 50, that's going to give me 7. 7 times 7, 49. 49 from 50, 1. 7 in, I have to put another 0 after that one now. 7 in 10, I have 1. Now I have 7 times 1, 7. Subtracting that 7 from 10, I have 3. So which means I will continue like that, like that, like that again. You understand? So I will have unending decimal. Unending decimal. So we are going to talk about this and other stuff. So there are several situations that can arise. And that is why we always have something we call rounding up to 3 decimal places, to 4 significant figures. Those are the situations that arise. Because if I continue with this process, it will be unending. And that is why after some time, it's okay. Towards this, once you get to this level, it is acceptable. Now, let's look at 1 or 2 situations like that. Now, just like I did, now, I did 3 over 7. So we can just do something like this. So 3, 7 in 3, 0. It's not that it is 0, absolutely. Less than 1. So we put 0 to show that it's less than 1, and we put points. That is what we are trying to achieve. So now you put 0 here. 7 in 30 now, you have 4. 4 times 7, 28. You have 2. Just like I said, any 0 you add after the points has no significance. So the number is still the same. 2, 7 in 20, we have 2. 2 times 4. 2 times 7, 14. So we have 16. Now, let me put another 0 here. 7 in 60. That is 8. 8 times 7, 56. 56 from this, we have 4. Let me put 0 again. 7 in 40, we have 5. 5 times 7, 35. I'm subtracting first. Take notes. I put another 0 here. 7 in 50, that is 7. 7 times 7 is 49. So I have 1 here. Put 0 again. 7 in 10, 1. 1 times 7, 7. I have 3. You can see, if I start this operation again, I will come back to these numbers again. So it will continuously be like that. So we'll come back to this. But for now, it is unending. We won't have it as a conclusive figure. At the end of the day, we will need to, approximate it, round it up. That's what happens. So we'll talk about rounding up the decimal numbers. And when we round up, we'll talk about significant figures, decimal places. Now, let's talk about rounding up decimal numbers. We can round it up to significant figures or decimal places. Now, when we are talking about significant figures, we are talking about the figures, how many figures that are useful, that are applicable. Yes, how many figures in this number that will be enough to express what you want to do or what you want to know. Let me give you an example. If I have something like 19.78 and I'm told to round it up to 3 significant figures. Look at it. I have 1, 2, 3. That is what I need. Which means that once you get to this level, I don't need any number afterwards. Maybe measurements, maybe when you are looking at the value. Like in some instances, if you are going to deal with hundreds of thousands, that is the value of figure you are dealing with is in hundreds of thousands. And at the end of the day, some units or tenths are there. You might say, oh, these ones are not really added to the figure. Their significance is not that important. So you can say, okay, to the 3 significant figures, to the 4 significant figures. Now look at this. If I want to approximate this one to 3 significant figures, I have 1, 2, 3, 4. But the last number is greater than 5. So what does that mean? It will increase the value of this one by the time I am approximating it, because it is equal to or greater than 5. So at the end of the day, this one will give me 19.8. Because this number, by the time I am crushing it off, it will be very, it will later be significant to this one. That by the time I remove it, I convert this one to a number that is greater than this one by 1. let's look at another one. If I have a figure like 1972, and I've asked to, round this one to 3 significant figures. You can see I have 4 figures, and the last one is not up to 5. So what do? Since it is not up to 5, I can easily crush it. And this one will now be 1970. You can see those are the 3 significant figures. The last one becomes 0. If there is a point here, I won't need any 0 again. It is gone. Now look at this. Let's make it 2 significant figures. Let's make this one 2 significant figures. If you look at this, I have 1, 2, 3, 4. I consider the third one because I need to convert to 2 significant figures. So this one now, since it is greater than 5, I will need to move this one up by 1. And so this one will now be 2, 0, or anything plus 1. Because third number is greater than 5. Now let's make this one to 2 significant figures. If you look at this, I have 1972. The third number is greater than 5. The third number is greater than 5. So what do? And I want to change to 2 significant figures. So it's going to be, I add 1 to this. By the time I add 1 to this one, I'm going to have 2, 0. And this other one will become 0. You can see. So, to 2 significant figures, at the end of the day, this one becomes 0, 2, 0. So, at the end of the day, I'm going to have 1, 1 figure because it has converted this 9 to 0 and made the one in front to be bigger by 1 again. So, if it is less than 5, you crush down the immediate number behind the significant figure they are asked for. But if it is equal to 5 or greater than 5, you increase that one by 1. That's the way you go about it. Let me see if I can see another example. Now, look at this. We have to convert this number to round it to 2 significant figures. You can see. When you are counting the significant figure, you count from the immediate one that has value. All these zeros, you will leave them. It is from here you will check. So, to 2 significant figures, I have 1, 2. So, what is the third number? It is equal to 5. Which means that if I want to convert or round up to 2 significant figures, I will have to change this one to 1 when I add it to this. But if I don't, this one is equal to 5 or greater than 5. So, by the time I am crushing it out of the figures, it has meaning. So, I will have to increase this one by 1. So, it's going to be 0.001. This is 3 before 1, 4. You can see. So, all these other ones will not be counted when you are talking about significant figures. But if you have it like this, 0.101354 to 2 significant figures. This one has value. This one has value. So from this one, you count now. So it's going to be 0.10. That's what it will be. Because this one is not 1. So this one will become 10. So please take note. You will start from the value that has significance. That you will have to overlook any other zeros first. But if after the number you have 0, you have number, or you have 0, 0, 0, this one has started the significance of the figure. This one has started the significance of the figure. Look at this one now. If I have another number like 1.1354, so 2 significant figures. The significant figure starts from 1 outside. So points. The number after 1 is less than 5. So it will be 1.1 to 2 significant figures. So you can see. So always take note of that. With practice, you will easily get all these things. You have to go through exercises, and it is fun. You don't need any calculator or anything to convert to significant figures. Now let's look at decimal places. Now, when we are talking about decimal places, we are talking about numbers after the decimal points. We are talking about the number after the decimal points. Look at this. If I have 12.421 and I want to convert to or round to 2 decimal places, I have to count from this decimal now. They said decimal places. So this is 1, this is 2. So if I'm to convert it to 2 decimal places, it's going to be 12.42. Because the last number here, immediately after the 2, or the number after the second figure from the decimal is less than 5. So this one is going to be 1.42. 12.42. This one is going to be 12.42. Now, let's say I have another number like this, 0.0235. And then to convert to 2 decimal places. If you look at it, counting it from the point, I have 1, I have 2. You can see. And the next one is not up to 5. So at the end of the day, it's going to be 0.02. That is 2 decimal places. You can see. Now, let's look at another one. Assuming it is something like the 0.2354 to 2 decimal places. You count from the point, decimal point, and I'm going to have 1, 2. That is the second decimal point place. This one is 5. So to convert to 2 decimal places, I have to increase the last one by 1, sorry. So I'm going to have 0.24. So you can see the operation is similar, but where you count from matters. For significant figures, you start from the number that is significant, either before the decimal or after the decimal. It can be immediately before the decimal, it can be far from the decimal, far before the decimal, or immediately after the decimal, or far after the decimal. That is significant figures. So that figure that starts it is what that will determine where you stop. But for decimal places, this is what will determine where you come from. This is what will determine where you come from. For significant figures, you can count from before the decimal, or you can count far after the decimal. But for decimal places, the decimal determines where you count to. It determines where you start from and determines where it will end. So that is it. Now there are some times where after rounding up the figure, you have no choice but to put zeros that will make the figure as you want it to appear. Let me explain with this. If you round 1, 2, 6, 4, 5 to 2 significant figures, you know, you are going to have 1, 3, because this is the third figure. But because these are still whole numbers, you need to add 1, 2, 3. Actually, the number was 12,645. I want to round it up to 2 significant figures. You can't just write 13. It will make sense. So, which means that it is going to be something around 1,000. Something around 1,000. And that's going to be 13,000. These other zeros that bring significance to this number, to make it sensible, as this one, these zeros are trailing zeros. Now look at this one. 13.1 to 3 decimal places. If you write 13.1, after it, do we have any other figure? No. So, this is just 1 decimal place. You will need to put zeros to make it 3 decimal places. And that is, these zeros, again, are trailing zeros. You see? It did not really change the sense of the figure, but makes us to know that, okay, we are working to a certain answer. Look at this one. You cannot just write 13, because there is no point here. And you cannot say, okay, when you round up 12,645 to 2 decimal places, it gives you 13, it makes no sense. So for it to be sensible afterwards, we need to add these zeros to make it sensible. That is all about trailing zeros.